All right, Alberto, after a decade plus of doing wireless charging and data design with major OEMs, small OEMs, innovative OEMs, design houses, and everyone, around, we still get the same sentiment that designing magnetics and magnetics for wireless power is black magic. It's like this mystical art that can't be distilled down to science or objective, data. How true is that? And what myths do you want to dispel? What would be one myth you'd want to dispel on this?
Okay. Yeah, I still perceive as black magic when of course when you haven't worked on it enough and you really do not understand the underlying physics problems. Nah, that's how you call it black magic. I think black. Let's first start with the definition of how that term black magic comes is when you're an engineer trying to solve something and then something unexpected happens.
Yeah.
And you just don't know why that happened, and you don't have that intuition of why that happened. Right, like, you crank up the power and then things got hot. You understand why.
Yeah.
You just have to reduce the power. So thermal can be a very challenging problem, but it's not black magic because you know that all you have to do is reduce the power. Now, how to reduce the power loss, that can be very complicated, but it's not black magic because of that. Antenna is black magic because you did something that was supposed to help on antenna performance and it completely destroyed performance. And then that becomes black magic. So then what we've done, we started as an antenna design company. For us, it was black magic at the beginning, right? Because we just didn't understand things. But then if you go back to basics to all the physics behind it, then you find
the first principles.
Yeah, first principles. Yeah. Then you start understanding, okay, this is happening because of that. And then you start creating tools around those first principles to help you accelerate that design. And then you are kind of dismantling that black magic and creating processes for those. And then the other way to do it is to create an intuition. Okay, so that the magicians are the ones that may not necessarily have created tools around this, but have created this intuition of being a magician. Like, I know that this happened because of this, and then I changed these 20 things, and now I have a good antenna. So that in a very high level is where the black magic comes from, and kind of two different ways to dismantle the black magic.
Yeah, but the myth is that so I think what I heard you say is that the myth is that it's undescribable what happens in these systems. You can't distill that down to some root physics.
Right.
You're saying that's not really true. It's just not accessible in an obvious way to people that don't understand the interactions of a variety of different physics principles.
Correct.
At the same time.
Right.
So it's kind of it's not just Ohm's law. Like that matters, but there's other stuff that matters. And so when you start adding multiple physics principles in, it's not that you can't distill the science. That's the myth. You can distill the science. It's just you need to be well-versed in multiple types of science. And one way to do that is through tool development. So why don't you talk to me a little bit about how we've approached tool development in order to demystify and also make it so you don't have to be a PhD physicist to understand all of the waveform and resistive losses and all the different things that happen in these systems. But you can use the tools to make this more of a repeatable engineering project instead of a science-based exploration.
Right. So the approach that we've taken on tool development is to make a purpose-built custom wireless power tools that solve things for wireless power in a fast and reliable way. Okay, so fast and reliable are your key metrics.
So talk to me about some of those metrics, like how fast, how reliable, maybe in terms of design spans or time or something like that.
Right. So the gold standard of tools, ANSYS, CST, those tools for wireless power simulations, those can take it. First of all, you need to set it up right.
Sure.
Right. You need to set up the right configurations, the right meshing strategy in order to create the right output. So you need an expertise on setting up, because these tools are very general purpose. They can work for anything from wireless power to designing a 5G antenna, right? So you first
The ANSYS tools are very general. Yeah, you have to set it up for a wireless power outlet. Okay.
and then when you actually set it up right, it typically takes a simulation around 1 hour in average. Can be 20 minutes or 2 hours, but in average is around 1 hour.
That's what you're talking about
For one antenna design
with ferrite.
With ferrite, with the electrics, with the entire thing. Now, what we did is that in order to accelerate our design cycles, and in order to increase our ability to explore more designs, we shrank that hour about 200 times. Okay, so now we're doing things in seconds, and what that allows us to do is to transform an electromagnetic solver into an optimization problem that can be easily optimize and produce real impactful output, and at the same time maintaining the reliability and the accuracy of the solver.
Okay, so in a second, we can do what it takes an hour for ANSYS to do.
Yes.
And maybe even a little faster. Half a second, we can do what it takes ANSYS an hour to do.
Around that thing.
Okay, so that sounds amazing when you look at it from that perspective, but the devil's advocate in me would say, who cares? An hour's not that long. Like, in the grand scheme of things, if I'm designing a product that's going to be in the market for 3 years, who cares if it takes me an hour, 10 hours, 20 hours? It doesn't really matter that much.
The challenge is that you really don't need one simulation, right?
Okay.
You need, in average, an electromagnetic engineer can take 1 month to design a single antenna. So it's 1 hour, but the human in the loop timing becomes 7 days, right? Because each cycle of simulation is 1 hour. If you reduce that to seconds, then your entire design cycle reduces from weeks or months into hours.
Okay, so on a unit economics basis, one simulation at a time, we're talking about hours versus fractions of seconds.
Right.
On a totality of the program basis, we're talking about weeks versus days, or months versus days.
I would say months versus days, or even weeks versus hours.
Okay, so that means a lot. That's a big deal. That's the difference between launching products on time and not. So is the quality different, or do you end up getting the same performance? It's just a matter of time savings.
On our applications, most of the time you start getting same or even better accurate performance, because we have tailored these solvers to be as accurate in wireless power as anything else.
That's impressive. That's not what I was asking. So we'll keep that. What I was really asking about is the performance of the product. So I'm not about the performance of the tool.
Yeah.
I'm playing the role of a product owner or an antenna designer. Will my wireless charging be better in the market? Will it be faster, cooler, smaller because I use GENA, or am I getting the same results as I would from ANSYS? I'm just getting a lot faster.
Yeah. So the strategy of GENA is to include all of the technologies that we have created here in NuCurrent into a tool that leverages those technologies to produce the best, most differentiated output. So if you look at the products that NuCurrent has created, they're widely differentiated against others in the market.
Partly this is because of the iterative ability of GENA, where you can solve problems in parallel so much faster than in the linear long form version from ANSYS. So part of it's how many times can you do the problem? But the other thing is you're leveraging a decade plus of NuCurrent's IP and launching more products to mass production across categories than any company in the world. So we have all this nutrition of good intellectual property and data, and that really moves the needle on the overall quality and performance of the product.
Right. Okay. Yeah. Another way to say it is that the data that we're using for this optimization algorithm is not a data that you can just find online. It's data that we have created for a decade plus at NuCurrent that we're now leveraging. Instead of having it just leveraged by our engineers to create new products, is being leveraged by these optimization tools to create the best solution possible.
Yeah. All right. So we've been using these tools for a couple years now at NuCurrent internally. Are others able to use the tool yet?
Not yet, but we're working on it.
Okay. So that's something that we have on our roadmap we're looking forward to. But as of today, the best way to access these tools is by contacting us. We will run them for the benefit of your product and collaborate with you. But we do have a plan to make these public or make them available to select partners, let's say, at the right time. So I'm sure this is going to make a big change in product development cycles, and I'm excited to get it out there for them.
Yeah, me as well.